I am Shauna Gilliland and I am your pre-calc teacher. So what I want to do today is I want to show a couple examples that some people have asked questions on. One of them is this question number 5, which they're giving a piecewise function and a table. In this problem, what you need to do is to determine which function, we'll call this function 1, with the negative 1.97x plus 26.3. So function 1, we'll call this bottom one function 2. So what we have to determine is what function is being used to determine our y values for our revenue. So to do this, what you're going to do is you're going to say, okay, let's start with 1. So what we're going to do is we're going to plug in 1 to one of the functions. And then you're going to calculate that value. Now, what you're looking for is that value to come close to 5.2. And I think when we did this, they were a little bit off, but they were fairly close. So what you're trying to do is determine which one of these values, or which one of the values is going to be used by which function. So for instance, and I'm not saying it's what happens or what the answer is, but if 1 through 7 was working for this function, that would be what I would list for the domain for that function. I would list 1 to 7. Okay, so but you need to check to see, is it 1 to 7 or is it 1 to 6? And then that would be for the first function. Then you would do the same thing to find the domain for the second function. Okay, so you will need to check each value and see which function, function 1 or function 2, is producing these y values. Okay, the other question that I've seen quite a bit is question 6 here, which is talking about the equilateral triangle. So what they're doing is they're saying, okay, if I have a triangle, oops, let's get rid of that. Just draw it. Okay, if I have a triangle, we're going to say it's an equilateral triangle, and it says the side lengths of S. So we're going to have S here, here, and here. It says find the base of the equilateral triangle in terms of S. Well, if you're talking about the base of a triangle, in this case, our base would be this bottom piece here, which you can see then is just S. Where the issue came is, say, in the second part. What we have to do is figure out what's going to go in the blanks. Notice that there's a squared on the outside. To be able to do the Pythagorean theorem, though, we have to divide this triangle in half. So this would be the height of that triangle. Now, the length of this 1/2 of this triangle, which we're going to look at just this piece right here, isn't going to be S, it's going to be 1/2 S. Okay, so if you think of your Pythagorean theorem, it's a squared plus b squared equals c squared. So in this case, we would have a squared plus b squared equals c squared. And then you can figure out from there, how do I get it to fit into that? I need to solve for h. Okay, once you have solved for h, then you're plugging it into your area formula. So you'll need to kind of look at the different pieces there that you have come up with. You've come up with the base, you've come up with the height, and then you need to divide it by 2. Okay. So the other thing that I want to do is kind of introduce what we're looking at this week. So there's really a few main concepts. The first one is your transformations. When you're talking about transformations, you're talking about shifting and stretching. So if we have a function, and we're going to deal with our function y equals x squared, or we can say f of x equals x squared. So if I take my function, and we're going to take this basic quadratic function, and we add some number to the end, that's going to shift my function up 2. Okay, so we have a shift up. If we changed it and said we have f of x equals x squared minus 2, we're going to shift it down 2. Okay. If we put a number on the inside, so say x plus 2 here, so we'd have x plus 2 quantity squared, this is going to shift us to the left 2. If we change it then to x minus 2 quantity squared, then it's going to go to the right 2. So those are shifting, that's just our translations. We're going to shift it up, down, left, and right. The other thing that we can do is we can stretch and compress our functions. So if we put a 2 in front of that x squared, that's considered a stretch of 2. If I were to change that though and say 1/2 x squared, it's a compression of 1/2, or sometimes they call it a shrink. Okay. The other thing that's in this lesson that sometimes gets a little confusing is odd and even functions. So if we're dealing with odd and even functions, let's start with odd. An odd function is symmetric about the origin. So what I mean by symmetric about the origin, so if you think in terms of a cubic function, so if we look at just our basic cubic function, we're going to say that goes through the origin, that would be symmetric about the origin. What has to be true then is f of negative x has to equal negative f of x. So that always has to be true if we have odd functions. Okay. Even functions are symmetric about the y-axis. Whoops. So when I say symmetric about the y-axis, if you just think of your basic quadratic function, that would be something that's symmetric about the y-axis. Okay. Now, with even functions, f of x has to equal f of negative x. Okay, so this always is true for every even function. And really that's everything in the first section. The next section is composite functions. So it could be doing f composite g of x, or it could be just adding functions together or subtracting them. It could be multiplying the functions together, f times g, or dividing them. So it's doing all different types of functions. Okay. The last section that you have for this is inverse functions. So you should be able to find an inverse function algebraically, but you should also be able to look at a graph and tell if they are inverse functions. Algebraically, what you have to do is you have to switch your x and y and solve for y. Now, when you're finding an inverse, the notation, you would say y to the negative 1. That's the notation for an inverse function. Now, graphically, okay, so graphically, what do we need to look for? So if functions are inverses, then they need to be symmetric about the line y equals x. Well, what's the line y equals x? Well, it's the diagonal line that goes through here. Okay, so for instance, I could have a function that looks like this, and another function that looks like this. And those two functions, because they are symmetric over that line y equals x, would be considered inverse functions. Okay, so that's really what we're covering for this week. If you have any questions, make sure that you contact me, and I will get back to you as soon as you can. Have a good day. Have a nice week.